Hello, everybody, and welcome at Wagon's Berlin first demo day on 2021. Amazing to see how many people are already joining the event. I can see our students, I can see our TAs and teaching assistants and teachers. Amazing. Welcome, everybody. Also, the friends and families of our students who are here to support them. Welcome, and I'm really happy to host tonight's event. Tonight, we're celebrating batch 532, the Data Science Bootcamp graduates. I would like to introduce myself a little bit. I am Andrea. I am the Events and Community Manager of Wagon Berlin, and I am really, really proud to be the one who opens tonight's event. Before telling you a little bit about how the event is going to take place, I would like to give a big round of applause to our 31 students who did so great and amazing in the past 9 weeks. Even though the circumstances were not the friendliest, you guys were so active within the community. You were so nice, so kind, and I want to thank you and congratulate you all super much. And of course, to send a big shout out to all our teachers and TAs, without whom we would probably not be here right now. So big up to everybody. Now, in a few seconds, my colleague, the city manager of Wagon Berlin, our lovely Annie, is going to join the stage, and she will present a little bit the structure of the bootcamp so that also people who haven't done the bootcamp yet know what to expect. And you can see clearly what our students have learned in the past 9 weeks. Before ending everything, I would like to ask you to use the chat room. Please feel free to socialize there. Let us know where you're from. Let us know if you're friends or family or maybe alumni we have around us. Don't be shy. Use the chat room. Also, please keep your cameras on if you're feeling comfortable, given the fact that we're not in person and we cannot hear any applause in the background. I believe it's nice to see some smiles and some happy faces, and I'm pretty sure everybody will appreciate them. So it would be nice to see you, but make sure to keep yourself muted throughout the whole event. Well, yeah, I think that's all from my side. I'm really happy. Welcome again. Good luck to the 31 students. I'm super sure you're going to nail it. And for the audience, grab a drink and enjoy. Meanwhile, I'm inviting our lovely Annie on stage. Hello, darling.
Hello, good afternoon, evening, everybody. I'm very happy that we're finally here. In a second, I will share my display, but first I want to put a little disclaimer. I am a little bit, I'm completely tackled down with hay fever. So if you hear me sneezing throughout the whole presentation, it's not Corona, okay? We're safe here. It's just a hay fever. Perfect. So let me share my display with you. And I think you can see it now. Can I get a little thumbs up from Andrea? Perfect. So thanks so much for all of you for joining us here. As Andrea said, I am Annie, city manager of Wagon, alumna of 322. That's already web development bootcamp in the end of 2019, so quite a while ago. And very happy now to work here at Wagon itself. I first want to start as well with a big thank you for our team. The team has been working very hard in these circumstances indeed. Fully remote, but I think I'm confident to say also in the name of all of the students that we've enjoyed it a lot. So thanks so much for everybody for being here and doing so much your best. So we have 8 amazing products today. But first I want to give you a little bit of introduction about Wagon and what is it actually. So I bet most of you had any of these issues. One of them might be you have an amazing model in your head. You want to find something out, but you don't have the technical skills and you don't really know how to set this amazing model up. Or you're working with data analysts, data engineers, and you don't really know what they're saying. Like you can't challenge the data, you don't know what they're saying, they're speaking kind of an ancient Greek to you. Or you want to switch your career, you have a little bit of foundation already in the skills that you have, but you don't know exactly how to swap and where to go. So you're basically like this. You don't have a clue what you're doing. So that is actually where Wagon comes in. We bring technical skills to creative people like you, and we make sure that you can land your dream job after an amazing 9 weeks with us. So what we do is we can give you the foundations to find a job as a data engineer. We can help you to become a freelancer or digital nomad. After the corona restrictions are gone, you can go freely wherever you want to go. Or you can find the perfect algorithm, launch your own startup with a beautiful idea that you maybe already started working on during the bootcamp itself, or you can transition in any data role that you have in mind. So how do we do it at Wagon? We have two different bootcamps. The first one is the Web Development Bootcamp. It's a full stack bootcamp where we teach where we train our students to learn within 9 weeks to set up a fully functioning web app. And we'll show off in a little bit what kind of beautiful products and projects our students can set up after the 9 weeks. What do we teach? In the full-time bootcamp, you have 9 weeks. In these 9 weeks, we push our students to at least work at 360 hours. I think it's kind of an understatement for our students. If you ask them in a little bit, they've been working really, really hard. The cool thing is that we learn a lot. Think about Python for data science. We're going SQL and databases, statistics, machine learning, neural networks, a lot of buzzwords that we also heard here in a bit. And everything that we teach is geared towards setting up a project and a product that's actually useful in the real world. If you cannot take off 9 weeks for your study or your job, we also have a part-time bootcamp coming up, and that is where you learn exactly the same within 24 weeks. So you touch upon the same projects, same topics, but just a little bit slower. We actually have gotten pretty good at it because we're the #1 rated coding bootcamp in the startup part of Europe. And important, of course, to know is where our alumni are ending up. Because of course we can be a nice rated company, however, you do the bootcamp, you invest a lot of time for something that you want to know. So we have data engineers, data analysts, data consultants. They either join a company or they set up their own companies and themselves. Out of the Wagon bootcamps, there's over 100 startups already founded by our alumni. That's something that we're of course super proud of. The big words or big names already in Europe. And we're also very proud to say that they already raised over 100 million already in total. So who are these alumni? So take, for example, Danny. Danny used to work as a design thinker and coach, realized that he actually wanted to go in a different direction. And he's now working, we did our bootcamp, of course, and now he's working as data analyst and analytics lead for Paul Kemper, one of the coolest startups and I think most useful startups soon as well here in Berlin. Then we have Francois. Francois, he used to work in sales. He then realized it's not necessarily something that he wants to do for the rest of his life. So he did our web development bootcamp first here in Berlin, learned how to code, and was really getting into coding, but realized that he wanted to do more with coding. And did our data science bootcamp in Paris, and now he's working as a data engineer at Papernest. And then we also have Brigitta. She did business school, was working as a trading intern, realized it's also not something that she wanted to do, and then did our bootcamp. She's now working as an innovation and digitalization data consultant. So that's, of course, 3 amazing stories about 3 people that completely changed what they were doing, but how can you actually make this happen? So there's 3 different funding options for our data science bootcamp. One of them is self-funding. Another option is financed by the German state. This is basically the option for people that are unemployed at the moment and want to do a further education. You can get a voucher from the government, and that is a voucher that's covering the complete tuition. So you can do the course completely for free. Another one is, another funding option is our income share agreement with Janssen. And Janssen is our partner that will pay the entire course fee up front. And then after you found a job that's paying more than 27K per year, you start paying back in little parts. And you make, with this payment option, you make also the bootcamp possible for next generations. So what do you get for this investment in our bootcamp? You get a lifelong access to our learning materials, our cheat sheets, our challenges, our lectures. They're all recorded. They get updated every time, so you can just always re-see and revisit what we've taught you. You get an amazing network of 10,000 students all over the world, in 40 different cities already, which you always can reach out to. And you get a lifelong access to our community. I think that all of us were super proud of the batches that we've been part of, and we were always reaching out to everybody around us. So that's one of the parts that you're getting. And yeah, our upcoming bootcamps these are the starting dates soon, and we're super looking forward. You can still apply if you want to, so that's great. And then yeah, I'd like to give the microphone to Zuza.
Thank you, Annie. My name is Zuza. Basically, everyone knows me as Zeus. And together with my partner in crime, Ben, I've had the pleasure to lead this bootcamp and see our students grow immensely from the very beginning. And it's not my place to say anything right now. Let them actually tell you what they've learned. And let's start with the first project. I hope that there are some art lovers among us tonight. If there are, you can show me some love, some reactions, type in the chat. And if you are an art lover, I know you probably spent endless hours on looking for that one amazing piece for something for your living room or for an inspiration, for example, for the day. But I have some good news for you because you don't need to do that alone anymore. And one of our project groups has a solution for you. And Severo, maybe you can actually tell us something about what you've been working on.
Yeah, hello everyone. Thanks, Luz, for the introduction. My name is Severo, and together with my team, we worked on Vincent van Gogh. Vincent van Gogh is an app that will let you discover your new favorite painting. So suppose you're on a nice beach and you're a great photographer, so you take this amazing picture of the sunrise, and you start wondering whether maybe in the past some famous painter was inspired by a similar view and created an exceptional piece of art. Or maybe, as Zeus mentioned, maybe you're in your living room and you're staring at this painting, which happens to be in your living room, and you really like it. And you're thinking, okay, I would like some more paintings like this one in my living room, but how can I easily find them? And that's where Vincent van Gogh will come in handy, and I'll show you how it works. So you can access it via vincentvanGogh.com. This is how it looks like. So the first thing, you can select how many similar paintings you want to get back. Then you can select, for example, the picture that you want to upload, such as this sunrise picture. And voila, you get two paintings that are very similar to the picture that you uploaded. For example, this one is a boat and the sea. This one is exactly the sunrise. I really like this one. But maybe you don't have a picture to upload, but you know the title of your favorite painting. So if you can come down here, you can, for example, type the title of your favorite painting, and you select it from the dropdown. Our machine will find the painting and return the most similar results. So a portrait, or in this case, another painting that has very similar colors. So it looks great, right? And looks also easy, but actually it's not that easy. And I'll try to explain you how it works in the backend. So when a user uploads a picture, the first thing that we do is pre-process the image. Basically, what pre-process the image means is that we transform the image into a long list of numbers, where each number represents the color of each pixel. At the same time, we send that same image to the Google Vision API, which is a product from Google that returns keywords that are connected to the uploaded picture. So in this case, we will get back both sunrise and sea. Then we would use the pre-processed image to, via some machine learning technique, we would look for paintings in our database that have the most similar pixel structure, like these three. So basically colors and shapes. And using the Google Vision API results, we basically discard the results that have the least number of keywords in common. Same goes if you don't have a picture to upload and you select the title of your favorite painting. So you enter the title, our machine looks for that painting in our database, and then it follows basically the same type of process. So we pre-process the image, we send it to the Google Vision API, and then at the end, we get this type of results. So this is our product as of now. They're going further. What we could work on is, for example, use a bigger data set. As of now, we're using a data set of only 32,000 paintings, but we know sources that can provide bigger data sets. And the second thing that we could work on is that currently in our database, we not only have paintings, but we have also other forms of art like sculptures and architectures, but we are not using them, and we could include them in our model. And the last thing is that we could fine-tune the interaction between the model working with the pixel structure and the output from the Google Vision API, and fine-tune how they interact with each other. So I would like a lot to thank my team for their efforts. Just for fun, we uploaded our profile pictures to the website, and apparently we are all saints, besides Mao, that is the evil guy of the group. But wait, there is actually more. We built the same app also on Telegram, which is messaging app like WhatsApp. And now in a second, I'll show you how it works. So I'm sharing the screen of my phone. If I go on Telegram, this is the Vincent Van Bot bot. You can find it via name. If you press on start, basically, it will ask you for a painting or for a picture. Let's upload the picture of a sunrise that we showed before. Let's ask for 2 paintings back. So very similar to the website. And boom, there we go. We got back the results that we were expecting with the nice description and links. And then the same thing we can do with the painting title. So if we enter girl, even if you don't remember the entire painting, we will find it for you, so we can select it. Then let's ask, this is the painting. Let's ask for the for 3 results back. And there we go. We got our results as expected. And yeah, thanks a lot for your attention. Again, thanks a lot for the efforts from my team, and I hope you'll enjoy our app.
Thank you so much. Super well done. I love that we can have like a pocket little advisor when it comes to art. So everyone make sure that you check it out. And when it comes to art, I always think about feelings, like we can express ourselves through art, but I also know how important they are right now after basically spending the entire year in a pandemic. And I think that every single person went for a really difficult time, and nobody was really prepared for it. But actually, maybe we could be prepared better for the next time if something like this happens. Hope not. And Veronica, could you tell us what we could do to prepare better?
So I would like you to stop for a second and catch the feeling that you feel when I say COVID-19. Is it fear? Is it anger? Is it stress? Our decisions are definitely controlled by our emotions. Political decisions, commercial decisions, family decisions. The data does not drive our decisions. What drives our decisions is how we feel about the data. Do we trust our government? Do we trust the information that we receive? These questions were in my mind and in the mind of other 3 people 2 weeks ago when we started this project called PsyCOVID. But before I tell you the details, I would like to introduce you who we are and why we are here. So we are a team of 4 coming from diverse backgrounds that 3 months ago decided to jump into this world of data science. And the team is formed by Suruti, Antonio, Wojtek, and me, Veronica. It all started when we came across a global survey that was done during this pandemic situation, asking different people to assess the different psychological aspects of their personality. And there were over 150 participants distributed in more than 100 countries all over the world. And we started to ask ourselves the same questions that the people that developed the survey. What is the impact that COVID-19 is having in our psychology and our behavior? And we wanted to take this a bit further and see if we could use machine learning to predict our feelings. And this is super cool, because if we can do that, it means that we can potentially also predict how humans are gonna behave. And this is basically the basis of machine learning and artificial intelligence nowadays. So we started this journey with a very clear goal in mind. Let's try to predict my level of stress and loneliness when a situation like COVID and a pandemic comes. And without many more words, let's go into the action. So over here on the left, you have a panel displaying different questions that are the same questions that the people answered during this global survey that I was talking a bit before. So for simplicity reasons, I will go over the first 3 with you today. And I would say I'm a person that I'm often concerned, that I easily get nervous, and that I'm also not so good at staying cool in stressful situations. And when I fill these questions, what I get is a profile of my personality in the shape of a pentagon, as you see here. And basically what this is telling me is which score I get in 5 different personality traits: extraversion, neuroticism, openness to experience, agreeableness, and conscientiousness. So the way this works is that the farther I move from the center, the higher the score and the more I am towards this type of personality trait. And this is awesome, because basically we just use machine learning to profile my personality. And putting this together with other demographical aspects, we could predict my level of stress and also of loneliness, which are 2 critical feelings that are important when when a difficult situation like COVID-19 comes. So machine learning is telling me, hey, Vero, look, you're gonna feel quite stressed and quite lonely if you live a situation like this again, and I can act accordingly. So psychology and machine learning are 2 disciplines that definitely complement each other, but that can really make a difference in the future by joining forces. And we realized by working with this data that we are just seeing the tip of the iceberg. And we could even take this further and use it for more things. For example, we could try to develop a recommendation system to tell me what things would help me or what things I should avoid in order to feel better during a pandemic. And we don't only wanted me or the user to see their psychological profile or their stress and loneliness level, but we also wanted to give some insight into the analysis, into the data that we are working with. And for example, I can select here some countries, and as you can see, we have a graph here depicting my levels of the levels of the population in these 2 countries in consciousness, agreeableness, extraversion, openness, and neuroticism. And this is super cool, because basically you can compare the situation in the countries all over the world. And we can add more countries, and you can see how the situation looks everywhere. And we also wanted to use a bit of the time to tell you how this is working behind the scenes. So basically what we did as a user, I just filled 3 questions with you, part of the 15 questions that come from a survey here on the left, which we used as a starting point by using a programming language is very well known called Python. And we cleaned the data, we pre-processed, and then we got like a final database to work with. And we use some important tools around that are available for us to depict the graphs that you just saw. These questions are the base for our machine learning models. The first one we use is called KNN, which basically is based on distance and similarity. And thanks to this, we could profile my personality and the personality of whoever access our website. And not only that, but we also use another important machine learning algorithm that is called Ordinal Logistic Regression, and basically classifies based on different intensity. And that's why we could see the differences in stress and in loneliness. And the coolest thing ever is that this is not only in my computer, all the information is stored in Google Cloud. So basically, this means that everybody can access from it. And you can also go from your website, from your preferred browser, fill in the survey, and in 2 minutes you get a profile and your level of stress and loneliness. And this is like super powerful. We were very excited to work in this project, and this is not only me, it has been an incredible, super intense week with other 3 people, roller coaster of emotions, super nice time, and yeah, amazing everything. I really loved it, and I think I speak for the 3 of us, for the 4 of us. So thank you so much, and thank you all for your attention and for being here today with us.
Thank you so much. I think everyone right now, or maybe not right now, but later, should actually go to this webpage and check out what is their situation. If you're stressed, actually, if I'm stressed personally, I always run away into music to relax, to let out all my emotions. And I usually go and use Spotify, but I know that there are some vinyl lovers in here. And actually, Tobias has a pretty cool tool to share with you. So Tobias, take it away.
All right. So first of all, I hope that you all see this right now. So yeah, I think as you all know, obviously, we are part of the data science batch from Berlin. And I think it's also quite commonly known that Berlin is not only the capital of Germany, but also the capital of all hipsters. And of course, living in Berlin, you kind of adapt to that slowly. So you start doing things like drink mate all the time, maybe even try to grow a man bun over time, and maybe even start collecting vinyl records. So we find ourselves from time to time in maybe a small record store or at a flea market, looking through records and maybe finding a record that we think is quite interesting. So I have, for example, here a record that I think, okay, it was interesting. I might think about buying it actually, but I might have some problems that I would have to face, like what's the actual price? Is it a fair price? What do other people think about the cover or the record? Are there any similar albums that might be quite similar to this one? Or also, does it actually fit my musical taste? So now, sorry about that. So now, Crate Scanner is the app that actually answers all these questions. And now for a quick demo. I will move over, and this is actually my phone right now. So as you can see, I'm using this right now on my phone, and this nice little software lets me mirror my phone to the screen. And what I will do now is click on Upload, Browse, Take Photo. And I will actually take a photo of my album right now that I have right here. Say use photo, crop it a little bit. And send it to the application. So before I actually show you the results of our application, we would like to actually show you how this is working. And for that, I would hand over to Wes.
Thanks, Toby, and hello, everyone. My name is Wes, and I was tasked with sourcing and organizing all of the data for this app. So first, our algorithm needed to be trained on certain albums. So the first question became, how do we decide which albums and artists our app should recognize? Luckily, all of the data for the most popular albums is already very easily available. BestEverAlbums.com is a database that collects the top 50,000 albums based on a number of really interesting features, including sales and ranking. We decided to start with one of their data sets to increase the likelihood of our app catching a match, just in case it was caught out in the wild. And moving on to the next task, we needed to make sure that we had all of the information needed for each album we had. For this, we utilized Spotify's API. And to put it simply, an API is simply a messenger that tells the system what we want and then gives it back to us in the form of a response. In our case, we wanted information related to an album, such as an album's cover image, but also for the album recommender, we also needed things like audio features, which allowed us to compare songs. Luckily, Spotify's API also provided really interesting information regarding the tempo of a song, its danceability, acousticness, and a bunch of other really neat features that we then added to the data set. Once these audio features were collected, we simply measured their numerical distance to one another, grabbed the 3 closest albums, and suggested them to the user. This method of grabbing the nearest albums based on the closest features is an algorithm known as k-nearest neighbors, or more commonly known as KNN. And now I'll pass it on to Barris, who will talk about the machine learning and image recognition.
Okay, thanks for that, Wes. Hi, I'm Barris. I'm going to talk a little bit about the image matching process that we used. Basically, we used something from the mysterious world of deep learning called convolutional neural networks. CNN is basically the go-to model type for image processing. It scans over the image in blocks and interprets these into what we call vectors. With transfer learning, we're able to use a pre-trained model that has performed very well on large data sets to extract features from the images, such as shapes and lines and other objects. So basically, as I say below, we transform the images into kind of sets of numbers, long digits, and then use a numerical formula to compare them to find the closest match. However, how do we know how well our model works? In order to check how the model was performing, we needed to find a large set of test images to test it on. And we figured the best way to do that was to look at actual pictures that people had taken of vinyl albums themselves. So we created a web scraper that essentially took many different pictures from eBay of vinyl albums from many different angles and lighting conditions and things like that, so that we would have a great variety of images. And then we tested how accurate it could predict the correct album from that. And a little bit for the data science people, we actually tested the accuracy of various models and also the accuracy of the different output layers as well, to kind of get the best fit between speed and data size, database size. And in the end, we went with the ZGG16 model, which performed the best out of all. Now I will hand on to Marie.
Thanks, Barris. So hi, everyone. I'm Marie, and in this project, I was in charge of the web scraping and putting all the different pieces of our code together, to eventually build the final application. Okay, so at this stage of the process, our model basically returns the artist name and the album name, but we are still missing the price and user review. So we knew that we could find this information on 2 websites, Discogs for the price and AllMusic for the review. So we decided to go with web scraping, which is basically writing a piece of code to extract all the information from the website and then get the price and the review from there. Yeah, so once this information were extracted, we could move on to the next stage, which was actually putting all the pieces together and build a final application. So on this slide, you can see a little bit how the process looks like. So from the moment the user uploads a picture, we're gonna basically use the algorithm that we developed to match it with our database, Spotify database. From there, we are able to get the artist and the album, and we feed this information to our web scraper to get the price and the reviews. And finally, we also use this information to feed the KNN model and get all the recommended album. So you can see a little bit here what's happening on the background, and we use all of that to build the application. You can have a glimpse below, but I think Toby is going to see you right now in a second how it actually looks like.
Yes, exactly. So coming back to our initial image that I took just 5 minutes ago, I think some of you might have already suspected it, that the album is Pink Floyd, The Wall. And as we can see here, it matched the album correctly. So we have the artist name there, the album name, as well as the minimum price from Discogs. I think it's listed here as $11.49. We can also drop the needle and actually test listen to the album. I hope all your volumes are not at the maximum. I hope that worked for everyone. And then also have the reviews in here about the album from AllMusic. So you have 2 reviews here, as well as the similar albums that are listed right here. 3 are listed here. So yeah, this is our app. But before I conclude, I just wanted to mention a big thanks to, well, basically everyone involved at Le Wagon for supporting us throughout this bootcamp and the project weeks. I would like to especially mention our head teachers, Ben and Zuza, as well as all of our TAs, and especially our head TA, Nisar. Without you, our project would not have been possible for us. But of course, also a big thanks to all of our team members, Marie, Wes, Barris. Thanks a lot, guys. It was a blast. And with that, back to you, Zuza.
Thank you so much. It's an amazing app. I've seen some comments in the chat that people are getting it right now. So you're getting already some popularity. But let's actually switch to something more serious right now. Please, I need a show of hands. Who has ever looked for a job? Yeah? Okay. Who enjoyed it? Okay. So one of the teams actually has a pretty good tool which can make the process much nicer and much easier. And Jasmine and Anna will now tell you about the product that they've been working on for the last 2 weeks.
Thank you, Zuza. So I'm sharing my screen. All right. Okay, welcome everyone. I'm Jasmine, and together with the team, we've had a really crazy 2 weeks working on this project, and are really proud and excited to show you what we've achieved. So, right, you all know the daunting task of searching for a new job. You go on a website and you start reading job offers that all sound the same. And in the end, you still don't know what role is fits to your profile, what is actually out there, what are the skills that are required. And this is especially true if you're looking for a new field. So wouldn't it be helpful if you could get a bird's eye view of the job market and understand which skills are important and easily find the jobs that you like? This is why we built an app. We want to make the job search more fun. So we built this page that you can see here, and you start on a bird's eye view. Our teammate Vlad, he wants to become a data engineer, so he can go and type in data engineer. And on the first page, you would see the overview of how many jobs are available from our database, how many companies are hiring. Then he would understand the top companies hiring are currently Zalando and Amazon. And then you can go further and check out the most in-demand skills. Those are categorized. So let's go and look at programming skills. So for Vlad, everyone who's been in class knows he's got Python down, he's got SQL down, and he's good on AWS, but maybe you should start on Spark to become the perfect match for a data engineer. Next up is the skill search. This is like my favorite feature of what we've learned in the bootcamp, because this is some math operations on words. I didn't even know that you could do that. And what it does is that you can enter a skill and that you will get out a list of skills that are very similar. So this is not just counts of skills that often occur with Python, but that are actually functionally similar. You can also type in other fields. I'm going to type in marketing and blob. Blob obviously is not a skill that exists, so it wouldn't be considered in our search. But for the combination of Python and marketing, you would see that analytics, Power BI, warehousing, and SQL and JavaScript are often requested. And we can take this even to the next level. Now we're not only searching for individual jobs, skills, but you can actually take a whole entire job description. So what we have here is a job description from AstraZeneca that I'm just going to copy the whole thing. Oops. Copy and then paste it here. Click the Analyze button. And now this is a pretty heavy model. So while this model is running, let's look at this job description. I'm pretty sure all of you have heard of AstraZeneca in the last weeks, months. So this is a biopharmaceutical company. They're looking for a data engineer in the field of oncology. So let's say that this is very, very interesting for you and you've applied to this one, but you want to find other jobs that are similar to this one. So what this will do is give you a list of other jobs that hopefully are going to be returned soon. And then you will see the details afterwards. All right. Well, maybe we will skip to the next one. I really want this to show you. Okay, I think I'm gonna hand over. Okay, there it is. Took a while. So here you see the list of job offers. The first one is going to be the most similar one. This one is a data scientist, head of data scientist in a biomedicine company. So you see here required skills. This is basically a summary of the skills that you need. And you can also already see that this is about bioinformatics and about cancer. So this is a job description very similar to the one that we've been just looking at and pasted here. Yeah, and then you basically just go and can apply to those other jobs as well. And what's behind this, I want to hand over to Anna to explain this to you.
Thank you, Jasmine. Hi, everyone. I'm Anna, and I'm going to show you a bit about the magic behind the scenes. So first, we started by building very complex scripts to scrape individual job offers on Indeed. And we also collected a number of job offers from Kaggle to about 6,000 job offers. We then pre-processed and stored these offers, and then we performed advanced modeling on these offers with a natural language processing approach that resulted in what you've just seen. And to tell you a little bit about which models we used, one of the models that worked really well is Work2Vec. this model is a neural network which learns word associations from text. So for example, if you have the word Python, what this model does is that it will take this word and run it through a number of mathematical functions which will convert this word into a vector that has a specific location in space, as you can see in the graph in the bottom. And the principle behind this is that words that are similar in our job offers will be close to each other in space. So to apply this approach to our offers, what we did first, we built a skills dictionary, manually curated, and then we took these skills and applied it to Word2Vec. And this model basically recommends the similar skills that are associated within our pool of job offers. Regarding giving you suggestions of complete job offers, we use a similar model, which is Doc2Vec. And the principle behind it is very similar to Word2Vec, but instead we copy a full body of text. And through analyzing the full body of text, we can find similar job offers, first by company and then by description of the job offer. So going further with our app, so one of the limitations is that our scraping approach is a little bit limited. It would be amazing if we could access an API which would populate our database with fresh job offers every day. Also, our offer recommendation for now only works with full descriptions. So if we had more time, it would be great to create a feature where the user inputs specific skills and gets job offers which match these skills. And finally, it would be wonderful to also create a feature that would look at your CV, create a matching score based on your skills, go through the job offers, and then find skills that match your CV. Yes, and with this, I would like to thank everyone. First, our dream team. It was amazing to work. The four of us put a lot of effort in this project. And I would also like to thank Wagon, everyone in the team, and especially Noor, Ben, and Zuza, which were there to hold our hand throughout this whole amazing process. So thank you.
Thank you so much. Actually, we have a career week for our students next week to prepare them for applying for the jobs, preparing for the next step. But I think, guys, I will put you in touch with our team responsible for the career week, because they could maybe actually use it to help you go into the job market even faster. Alrighty, so let's actually go back to art. We already spoke about it, but one of the teams came up with a solution to help you express your feelings, your thoughts with an image, but not any kind of image. It's actually an image that's tailor-made for you. And now Masha and the team will explain you how it's actually being done behind the scenes.
Thank you, Zuza. Hi, everybody. I am Masha.
Hi, my name is Erica.
And my name is Gergely.
And we are the team behind Artsy. So Artsy is going to help you, as Zuza just introduced it, to take your feelings, a text message you received, your emotions, and translate it into an image, not any image. And we know that an image is worth 1,000 of words, or as the classic famously put it, don't tell me the moon is shining, show me the glint of light on broken glass. And this is what is behind the idea to create Artsy. So what can it help you with is to enrich your communication, to maybe find interpretations and meanings for whatever text you're having, even translate it into the language of images, or send a greeting card with how you feel, how it is you feel at the moment to those you love. So without further ado, meet Artsy, the artsy storyteller. So here it is. Greg, would you like to say something?
Yeah, I would use what Chekhov said. That's a good idea. Let's ask Artsy about, don't tell me the moon is shining, show me the glint of shine of the broken glass. Let's see what he says.
Shine
On the broken glass. Oh, the
broken glass.
Yeah.
Submit, and while ARC is running, as you can see, we can also brainstorm some other ideas you could use it. So for instance, you had seen a piece of art which is immaterial art, which is taking kind of its momentum. And then you can retrieve an image and send it to your grandma from a museum or a gallery where you saw it, or a theater piece you're watching. Or it doesn't even have to do necessarily with art. It could be something completely different, and you just say it, and look what ARC shows us, guys. So the images are stylized, and you also have a chance to see the originals. So here we have probably moon shining, broken glass. Let's see what it initially took. Okay, so there is some space. There are explorations here, the glint, the splash. So that's basically it for the demo bit. You can go and do it yourself at the moment. Now a bit of what's happening behind the scene, the technical aspects. So the part where the text is entered then uses the natural language processing. We used Spacey, the really up-to-date, highly recommended open source NLP, so language processor, to retrieve these noun chunks. So we would say comfortable sofa as one noun chunk and blue window as another. Then what happens? It enters into the processing phase. In the processing phase, these chunks are split. So we take nouns, such as sofa here and a window there, and we feed them into content to retrieve a content image. Or we can take the adjectives in case that when there are no adjectives available, we take verbs and we retrieve the style. Then the mixing happens, and Greg will tell you what's happening in the mix. Thank you.
Thank you. Yeah, what's happening is called Neurostyle Transfer. It's neural because it's the model is kind of simulating the brain, how our brain works. And style transfer because it transfers the style from the style image and the content image. If you look at the screen, you can see the contents, they are kind of the sofa and some window. And downstairs you have comfortable and blue, and basically it mixes the images. So what you get there is what it does out of sofa and the picture of comfortable. Style transfer because it's learning the style of the image, which means colors, lines, some patterns, something that gets repeated. For those who are into programming and all these things, it's by TensorFlow. There's an open source library you can download it, you can play with it a lot. There is so much more than what we have used. It's a very powerful algorithm. We have used just a tiny bit of it to play. And basically, also the big difference between what is normally done and what we have done, that it's very useful if you want to transfer famous painter style like Kandinsky, Van Gogh, Monet, you want to see your picture, how Kandinsky would have done it. But we didn't do it. We used it for already existing, like more urban, everyday pictures. So that's why it's not the arty, not that kind of artistic inspiration it gives. And how it's communicated among these computers and things will be revealed by Erika.
Yes, hey guys. So besides learning how ARC works, you might also be interested in knowing how ARC is brought to you. So ARC's availability and functionality relies on a two-part system. The first part, the part which with you, the user, interact with, is called the front end. And ARC's front end is hosted on a cloud services platform called Heroku. However, all the calculations and the heavy lifting to process your input text and to fetch the necessary image and process them are done somewhere else. They're done on the back end. And the back end consists of a container, which is hosted on a multi-services cloud platform called Google Cloud. And you can think of a container as being a virtual computer, which is uploaded on the cloud and performs any kind of operations that you tell it to do. And the way that the front end communicates with the back end and vice versa is through an API, an application program interface. And you can think of an API as being like the waiter at a restaurant who takes your order at your table, brings it to the cooks in the kitchen so they can prepare a delicious meal, and then brings the delicious meal back to you for your enjoyment. And this is basically how Artsy is made available to you for your enjoyment. And with this, we wrap up our presentation. In the name of the Artsy team, we would like to thank you very much for your attention. Thank you so much to the Artsy team for the really hard work, for the very smooth collaboration, and for the really fun times and atmosphere in making our project come to life. Thank you very much.
Thank you so much. Like everyone can unleash their creativity, and I think everyone should try it out. It's like every time you can get something else. And I love the part when you just open the images and you see where it's actually coming from, and it's really so good. Okay, let's talk about money now. Over the pandemic time, I think everyone got caught up in that shopping frenzy, you know, Amazon ordering something every day just to have that excitement of getting new things delivered to home. But actually, I think many of us are also concerned with doing something more productive with our money, for example, investing. And there are different ways. One of them are cryptocurrencies, HEDL team and so on. But this is pretty risky and not everyone really understands how it all works. But I think that will change as of today. Daniel, could you explain to us how can you help other people with investing?
Yes, of course. 1 second. Oopsie. So our project was basically about using different kinds of machine learning and deep learning models to try and understand the cryptocurrency market and to see if we can find one that can predict the price with reasonable accuracy. Before I get into why I think this is an important project, let me introduce the team quickly. And of course, our respective supporting characters. So this is Vitali, Shayo, and me, and of course, a cute cat, a cute kid, and a cute guitar that helped us on the way. So why did we spend the last 2 weeks running deep learning and machine learning models on cryptocurrency? Well, cryptocurrencies are probably the most profitable assets in this century, maybe even ever. The amount of profit some people get from trading with cryptos is really, it's off the charts. It's not even comparable to any kind of non-leveraged stock trading. On the other hand, crypto prices are extremely volatile. And still, most people who invest in cryptos lose money, just like most people who invest in anything that is not a long-term investment lose money. How is this possible? Let me show you with a couple of charts. So this is Bitcoin's market capitalization. As you can see from this line going up towards the moon, a lot of people are investing in crypto. The market cap is above 1 trillion now, which is just a really big number. There's a lot of zeros in there. I couldn't even write it out on the screen. However, this is the price chart of Bitcoin for, let's say, the last bull market or the first part of the current bull market. As you can see, even though the direction of the price is very clear, there are these major corrections, 30% corrections, which are extremely, extremely big compared to stocks, at least. So a lot of people end up investing when the price is going up in the green areas, and because they hear from their friends that they're making a lot of money, and then a correction comes, it drops 30%. Oh no, the price is going to zero. This was a horrible choice. I have to sell everything while I can. and then they sell lower than where they bought in, and then they lost money. That's not very good. So obviously people are trying to get informed before they buy such a risky investment, but it's very difficult. When I was trying to get informed about cryptos, it was one of the most difficult topics in my life to get reliable information on. Most of the stuff online is just, it's just not even worth reading, to be honest. There are lots of analysts to help people with these problems, but of course, most of them are not reliable. And how can you tell if they're reliable without knowing technical analysis? This is why I decided to spend a couple of months learning technical analysis before I got into it. And this is why we created this product, so you don't have to do that, or actually you don't have to do it immediately, but you can maybe do it with our help. So before I get into the technicalities, let me show you the actual project. We created this little website to showcase what we created. Basically, it's a deep learning model that predicts the price one time step in the future. Currently, it's 1 day. And the accuracy is around 98 to 99% in this case on Bitcoin. That is extremely accurate.
Daniel, we cannot see your website.
What, sorry?
We cannot see your website.
Oh no, that's unfortunate.
Now we can see it. Go
Fantastic. On. Thank you, Tjerk. That was Tjerk, our lead TA. Without him, this would have not been possible. Not just the presentation, but the whole project. Okay, so you arrive on a beautifully designed, amazing website, and you select the coin you're interested in from this dropdown. You press predict, and then you get the prediction. If you want, you can also zoom in like this, and you can see that the prediction is that the price, unfortunately, will go down, and you can see these colored confidence intervals, which tell you kind of the range based on the accuracy of the model. We can find out tomorrow if that's true. And we also created these extra indicators, which I will go into in a second. So what does all of this mean? Let me just switch back to my presentation. Let's see. So can everybody see the phrase time series analysis on the screen now?
Yes.
Fantastic. Thank you, Tjerk. So time series analysis was our problem, analyzing data that comes in a series of time steps, basically. So in an ordered list where the numbers progress from one direction to the other. It's actually a very difficult problem from a technical perspective. And these were the three main types of models that we used to tackle this problem. Most of the time spent working on the project, as you can see from the website, was spent on actually testing the models so that we can be sure that we have the best possible predictions and that we tested what we did many, many times. So we can be confident about the numbers we present to you. So Facebook Profit is a type of machine learning model. Serimax is a similar model, but kind of easier to experiment with because it's more clear. Facebook Profit is kind of a black box. Serimax is easier to comprehend. Lstm is a type of deep learning model, which ended up being the most accurate. But as you can see, they all did reasonably well, but Lstm was the clear winner. Basically, we did a lot of predictions and a lot of different time steps with different hyperparameters to find out which results were the best. And and that's how we got that diagram with the prediction. And the other part of the result, which was the other avenue where we were working, basically encoding technical analysis techniques. So when you do technical analysis on stocks, there's a lot of other time series that you can look at other than the price. The RSI is one of them, which is calculated from the price and the volume, but it's usually taken as a separate indicator. And when it goes in this high, above 70% region, that indicates that a price increase is going to likely reverse to a price drop, while if it goes into the lower region, that likely means that the price drop is going to reverse and turn into a price increase. So we encoded this as this easy to read indicator. Basically, if it goes into the yellow zone or the red zone, it means that a reversal is likely. And then we have the Bollinger Bands, which is another commonly used technical indicator. Basically, if the price leaves the upper or the lower band, that means that what you're seeing is not just a micro fluctuation, but a significant price movement. So you can reach for the champagne to celebrate your gains or to drown your sorrow as you lose your money. So this is very useful because our model is more accurate if there are fewer micro fluctuations. So with the help of these indicators, you can also get an idea of whether what you're seeing is a micro fluctuation or a macro movement. Our future plans are to improve the accuracy even further with some ideas that we didn't have time to properly work out, on integrating more time steps, because interestingly, LSTM models can work with actually a lot of different time series and a lot of different time steps. So we could do multiple time steps if we manage to engineer it properly, and we could incorporate more time series because at the moment we were only looking at the price. We tried a lot of different approaches, but interestingly, the most accurate model only requires the price data. And then encoding more technical indicators, creating more of these intuitive gauges to help people get the insights out of technical analysis without having to go through hours of YouTube videos. And of course, custom alerts, so you can get an email or Telegram alert when your favorite crypto is doing something interesting to you. That was our project. Thank you for your attention. And also thank you to my lovely and capable and very, very talented teammates. And of course, Tjerk, our lead TA, and everyone else at Wagon for all of this knowledge that allowed us to create this project.
Amazing job. Thank you so much. Everyone, this project is there for free. So go there and use it while it's still actually for free. And you guys, careful of your servers because they may get overloaded with that. Just a side note, time series is one of the most difficult topics we are working on during the bootcamp. And I know that many of the students still remember the lecture very well in terms of how heavy it was. So this was a huge challenge for the team to tackle an issue like that. And they achieved amazing results because 99% is just mad. So very, very well done to all of you. And still, like within money, I used to spend a lot on traveling, which was obviously not possible in the last year, and I miss it a lot. But I really feel that it's slowly coming back and that I will be able to soon book my cheap flight tickets, start planning the trip, and then book the hotels. Right, hotels. I don't know if you ever experienced a really poor service from a hotel that had 10 stars, apparently amazing, but your experience there was just horrible. It's not easy to find the right place, but actually Jorge and his team created a tool that lets you actually see whether the hotel is worth going to or not. So Jorge, if you could take over and explain, it would be amazing.
Thanks for the introduction, Sus. Thanks, everyone. Thanks for your patience. I know already is a lot of information, demos. I promise to keep it short. Yeah. Revolution is the name of our project because we want to make a revolution on the online reviews thing. So first of all, I cannot forget my team. Thank you guys for the hard work. My team was Fabio, Andreas, Kilian, myself. Thanks for the hard work. I cannot believe what we achieved. Let's talk now about hotel reviews. Okay, hotel reviews, how important are hotel reviews? I found a statistic that 93% of the consumers are influenced actually by the reviews before they purchase something or they book something, okay? But reviews has problems. Not everything is super nice. Have you found a review that the score is totally different that it shows? Like, for example, I love the place is a must 1 star. So very good text with bad review, or the other way around, very bad text with good review. Yeah, and more problems associated with the reviews. The reviews now are used as currency sometimes. Let me explain myself. The customers sometimes tell the hotel, okay, I will give you 5 stars if you give me a free room upgrade, or the other way around. If you don't give me free breakfast, I'm going to give you a very bad score that will affect your average. And that is true. If a score of 10, if a hotel with 10 gets a 1, we have a problem. Okay, our solution is, instead of write something and give a score, just write something. We are going to extract the score out of the text, okay? Plus extract more information out of it, like topic or sentiment analysis. Okay, let me show you what we think when we made the first roadmap. We think, okay, let's write the model, let's set up the web page, let's create the packages, and let's put it all together, and we are done. Make the presentation. But we went find out is the reality, more than a simple road, was like a 4-lane highway with a lot of traffic, a lot of problems. I'm going to tell you some of the problems now. For instance, we faced the first problem. It was a regression or a classification problem. The difference between these two concepts is regression is going to give you a score, like with decimals, 6.53, for example. Our classification is giving out a category, like from 0 to 10, so 11 categories. We find out that it was a regression problem because when we get a 6 out of the text and really was a 7, we were very close, but it was telling that we were wrong, and that was not true. Another problem we had is that we had a lot of data. We had 500,000 reviews. So train this was a nightmare. So work with this amount of data was a nightmare. So the solution was with training with smaller samples. The smaller, talking about 50K, 100K samples. So it's a really good data set we had. Okay, let me talk now about the model. Some technical part, I will try to put it in an easy way. First, we had to balance the data set. What it means, in our data set, we had a lot of good reviews and not so much bad reviews. So we have to balance this data to make it more or less equal. Tokenizing and padding means that you take out from the text and you convert this text into numbers, so the computer can work with it easily. We use Lstm neural network. That is a very complicated, very advanced neural network. Sorry, actually, it's like neural network is like a brain, but in a machine. So a machine is imitating the work of a human brain. Okay, this you teach something to this brain, and then it learns. Then when it learns, it can give you something, an output. It's based on 30 layers, and it has overfitting control. Overfitting means that generalizes better. Okay. Let me show you the workflow and the apps we use. In the yellow part, you can see Jupyter, Colab, and Google Cloud. That is like notebooks for coding, but from less to more powerful computing power. We host the page in Google Sites. We test it in local. We host on Google Sites, and we connect this artificial brain with the page using a fast API. Okay, now let's go to the good part, live demo of the product. The product is already running in revolution.net. Let's go to a page, very well-known page with hotels. And let's go to the most famous hotel in Berlin, the Adlon Helsinki. Let's see the reviews. Okay, we clean the reviews, and let's take the first one, okay? The first one is saying outstanding and have a good part and a bad part, okay? Let's paste this into our tool, and let's remove the blank spaces, and then, okay, we clean review it. Now, this brain is working, this artificial brain is working, and it's trying to give this as a result. Let's go back to booking.com page. And we are going to check this review has a 10 score. If you look in top right part, it has a 10 score. Okay, so but actually has something good and something bad. Strange, because this is not a 10, no? Let's go to our app and let's wait until it gives us a result. Now it's warming up. Now it's trying to think what's the result in this for this score. Is this a super advanced model? Is a Lstm? Okay, we have a result. It's not a 10, right? You're saying something good, but you're saying something bad. Like everything was good, but there was a part, no plug socket near mirrors, rooms of the dark side. But this is not a 10. Our machine is telling us that is a 8.43. Let's take another one. For example, is Mastu with a 10. Okay, now amazing auto, everything perfect, blah, 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 very respectful. So look like everything is good. And let's review it. And now it's processing. Okay, 9.86. Yeah, this looks like more like a 10. Okay, that's more or less all for the live demo. And let's go back to the presentation. Yeah, this is only the beginning for our product. We are working on topics, so extract from the topic what's the review talking about, if it's about the room, is about the food, if it's about another thing, and emotions, because reviews now are I'm sad and happy. There are more human emotion, like I'm surprised, I'm overwhelmed. So we are working on this, and eventually we can work on automatic reply for hotels. For example, the room was bad or the room was very small, I'm sad. The hotel can automatically reply, oh, we are sorry that you're sad because of the size of the room, for example. No? Okay, that's all. Thank you very much to my team, to all the assistant teachers, especially Nisser, to Sus, Ben. Thank you, everyone. Thanks.
Thank you so much. Jorge, you got so much love for your presentation and the styling, apart from the model. So congratulations on that one, because it was like a fully comprehensive presentation. And I think you already can expect some investors calling in and trying to buy your product. Okay, let's go on to the last one. Last but not the least, let me proudly present to you a project which is one of its kind. It's not a typical data project that you've seen this far. It's actually something combined. So we've been very well known for our web dev bootcamp, full stack bootcamp, and we launched our first data batch last summer, and soon an idea was born to join forces with our web dev program. And both groups learn completely different things. On the web dev side, we have Ruby on Rails, we have JavaScript when we are building full stack application, web applications. On the other side, on data, we are learning Python, data analysis, and discovering all the black magic behind the mysterious data science. And we realized that we can actually use the potential of both sides during the project weeks and let the teams cooperate together. So with no further comments, Ricardo and the teams from both sides, so welcome our guests from the web dev sites, please take it away.
Hi, everyone. It's good to see all of you again after 2 weeks of working like crazy on our projects in separate breakout rooms. Welcome to the last presentation of the day. It's been a trip, and thanks to everyone who's made it this far. My name is Ricardo, and I am one of the members of the collaboration project between the data science and the web development batch. And I worked together with Antonios Fledos and Elias Lugani during the last 2 weeks. And also to mention our head teacher, Noor. And I have to say it was an amazing experience, and I couldn't have asked for a better team. So without further ado, let's get to the presentation. Our project is called What the Hell is This Actor's Name? It is a phone application used to find actors whose name you don't know, or maybe forgot, by using facial recognition and pictures of the actors, and in some other cool ways. But it is also an app that you can use to get some movie recommendations. We will start by showing you all the technicalities of how the program works in the background, starting off by explaining the movie recommendation system, following with the facial recognition system, and at the end, we'll show you the end result, an amazing application that you can use anytime from your phone. I have to warn you that there's gonna be some graphs, but I promise that we kept it as simple as possible, so hang in there just a little longer. Let's start with the movie recommendation system. I've always loved explanations with examples, so here are 4 of my favorite movies. They're all great, they're all famous, but apart from them all being very successful movies, what do they have in common? It can be hard to say just by looking at the pictures of the posters and trying to remember some of your favorite scenes. So how do we do this? Well, we have to break down the movies into characteristics that all of them have. In data science terminology, we call this features. So, for example, some features that these movies have are a director, actors, and genres. So let's gather now all of that information and start trying to compare the movies. There they are: Pulp Fiction, Django Unchained, The Wolf of Wall Street, and Ford versus Ferrari, and the features we chose: director, genres, and actors. We can think about this comparison between the movies with a point system, where the maximum amount of points is equal to the amount of characteristics of the movie you choose. So for example, for Pulp Fiction, we have 1 director, 2 genres, and 3 actors. That will be a total of 6 characteristics, so 6 points. Now let's compare Pulp Fiction with Django Unchained and see how similar they are. They have same director, that's 1 point. 1 common genre, drama, that's 2 points. And 1 common actor, Samuel Jackson. So 3 points for Django Unchained. And that's actually pretty good. Like, you could say that Django Unchained is a good recommendation for Pulp Fiction. So using this same logic, we compare Pulp Fiction with all of the other movies in the database. And we see that Wolf of Wall Street has 2 points for similar genres. And Ford versus Ferrari has only 1 point for drama. This means that if you ask for recommendations for Pulp Fiction, you're gonna get Django Unchained before all of the other ones in this database. So now that you have a basic understanding of how this comparison is done, we can dig a little bit deeper on how the computer actually does all of these calculations. For this, we have to first vectorize each of the features we have. That means convert them into numbers. And once they are numbers, we use the machine learning model called K-nearest neighbors. I hope you can see it. And it plots each of the movies in a multi-dimensional graph, as you can see here in 2 dimensions. Each movie is a point, and then it calculates the distance between each of these movies. The ones that are closest to each other end up being the movies that are the most similar, and the ones that are farther away are the most different. So if you want recommendations for The Dark Knight, you can see here easily that Dark Knight Rises and Batman Begins seem like pretty obvious, but we can see a little more into detail why this would be the recommendation. So for example, we compare with the Batman Begins, and they have the same director, 2 similar genres, and a bunch of same actors. So that will be a pretty good recommendation. We can see that Inception here is not as close, but also would be the 3rd closest one, the 3rd recommendation. And that is because they have the same director and 1 common genre. And we also have like a pretty interesting case down here with The Notebook, which is the one that's farthest away. And that is because it has absolutely nothing in common with The Dark Knight. So that is kind of how the movie recommendation system works. But in reality, instead of having just 2 dimensions as we have here, because it's easier for visualization, our model has about 16,000 dimensions. Luckily for us, like calculating the distance in 2 dimensions and 16,000 doesn't make a difference in math. So yeah, that's how it works. Now I'll pass you to my colleague Elias, who's going to explain to you the facial recognition system. Thank you very much.
Thanks so much, Ricardo. So I'm Elias. I work together with Antonius and Ricardo on the facial recognition part of the app. So let's say you're walking down a street, you see this poster of Pulp Fiction, and you want to know the name of the actress that you see on this poster. You take out your phone, you open the app, you snap a pic, you upload it, and the app tells you, this is Uma Thurman. So let's take a look at how this prediction is actually made. So the first part of facial recognition is actually facial detection. So we need to find the exact location on the image that you upload that contains the face. And we do that using a Cascade Classifier. A Cascade Classifier is basically a collection of weak models that are very stupid at it, on their own are very bad at making predictions, but together they vote and make up this Cascade Classifier and actually have a very intelligent prediction on what the coordinates of the face in this image are. So then with the coordinates of the face in this image, we extract the face, which we can then further input into our model. So the model that's already been explained by some groups before us is that we're using is the convolutional neural network. And so we take as input the face here of Uma Thurman. And in the beginning layers, it looks at low-level features. It looks at things like contrast or lines or simple shapes like circles. And from these low-level features, it builds more complicated features like mid-level features like eyebrows or pupils or noses. And then these mid-level features can be combined in later layers to high-level features, which can approximate entire faces. And based on these higher level, more abstract features, it can then make a prediction, which in this case is Uma Thurman. So now you hopefully have a better understanding about how the k-nearest neighbor and our CNN model work. And now I'd like to explain to you how these models actually communicate with the app that you're using on your phone. So when you take a picture or input a movie, this is sent to the application programming interface, which is a way for two programs to talk to each other. This API then passes it to this model, to the models, which run all the processing, which do all the work of making the predictions. And these predictions are then passed back to the app that you have on your phone. So thanks a lot for listening, and I'll pass you over to Margot from the web development team, who built a beautiful application that you can use on your phone to find out an actor and have movie recommendations. Thanks so much.
Thank you so much for the introduction and all this wonderful explanation. I'm Margot. I'm here tonight for representing my team. I'm really, really proud to introduce you today our app that we built all together with Anna, Matthias, and Gareg and myself. So are you ready to see it? Are you ready? So let's go then. So there it is. I'm sure you, like me, sometimes miss a bit some memory, especially with names. And actually, this is how the app came out. So this is how it works. I really have a name was stuck in my mind. I can't remember his name, but I'm pretty sure of two movies where he played in. So let's go for the first one. Let's type Inception. Yeah, great. Perfect. Yes, this is the first one. Let's go there. Oh, that's interesting. This is already the 4 top actor in this movie. And what is it below? Oh, it seems to be like some prediction. Wow, recommendation for some movies. Oh, I never saw this one. The Dark Knight Rises, which is the second one. Okay, pretty cool. And what is the last one? Tenet? Now I can probably trust it. It seems to know me better. So let's try out the second movie. Let's go for Juno. Yeah. Yes, perfect. It's there. I check it. Boom! It's working. Amazing. So I can discover more there about his life. But kind of interesting. I love it. And actually, I can find out a new utilization for this app. With this camera here, I have a friend who just texted me something like just a few minutes ago. What is she saying? She would like to watch with me a movie and with this actor. But I don't remember his name. I don't remember at all. So, okay, that's perfect. I'm just going to grab the app. Let's go there. And let's try it out. Okay, I'm gonna load it. Yes, there. and I think, yeah, it is working. That's fantastic. Whoa. And this is this app. And I really enjoy this actor. Now I have to remember his name, but actually, you know what? I don't have to, because now I have my app. Thank you so much.
Amazing, amazing job. Thank you so much for this amazing project and this incredible enthusiasm towards the end of our demo day. So what you could see is how we can connect the mystical data world with an actual app that everyone can use. And I just told you in the chat, if you ever approach me in the future and I don't remember your name, I'm really sorry, but I have a huge problem with names. Like, tell me Brad Pitt, I won't remember that name, George Clooney, and then. So we've reached the end. And I just wanted to tell you a little something. We did rehearsals for a couple of days. And I always really enjoy the moment when our students come to us and present us those really, really complicated presentations with all the charts, with complicated vocabulary. And they don't even realize how much they've learned over the last 9 weeks, because like when we were starting in January, they had no idea what actually a convolutional neural network is, or what vectorizing is, what overfitting, underfitting, and now they are just overwhelming us with all those crazy terms. So I just wanted to congratulate all of you, because this is just mind-blowing in terms of what you created and how well you were able to explain it, because it was just really, really friendly for, I think, for everyone here coming from the different backgrounds. And also for me personally, it was a really pleasant time to be with you, to transfer the knowledge for you, to support you throughout those difficult moments. Again, also be really exhausted together with you. So I really feel you. And it wouldn't have happened without an amazing, incredible team of teachers. And now I just wanted to thank everyone, literally everyone. So big, big thank you for Agnieszka, for Hai, for Kai, for Ryan. Thank you for Apik, Adrian, for Alice. Thank you, Chris, Clement, Frederick, Gael. Thank you, Gilles. Thank you, Greg. Thank you, Guli. Thank you, Gian. Thank you, Juan. Thank you, Linda. Thank you, Manuel. Thank you, Matthias. Thank you, Michelle. Thank you, Nico. Thank you, Vesi, Vishal, Alvaro. Thank you also for our amazing project team. Thank you for Bruno, Erifon, for Georges, who were supporting us as TAs during the full 2 weeks, which were really crazy. And of course, the leaders of the project, the mentors that were advising the teams throughout the way. So thank you a lot to Nizar, to Noor, to Tjerk, and to Killian. And of course, biggest thank you to my partner in crime, Ben, who was the other batch manager, and it wouldn't be possible without you. So Ben, giving it away to you.
Yeah, thank you so much, Jules. Honestly, it's been incredible. I can't believe that it's the end of 9 weeks already. I was speaking to some TAs like Killian, who was with you guys during the prep week, and he was telling me how incredible it was, how far you've come from the prep week, just like struggling with lists and basic Python stuff, and then doing neural networks 9 weeks later. It's just incredible. So yeah, really well done for all your hard work. Also, like, I just want to thank you because it's been incredible vibes, and in a full remote project to feel so close with this group and to have such good vibes and have so much fun actually remotely and in front of screens was really something else. So thanks for everything. I had really a blast over these 9 weeks. I hope you did too. So once again, well done. And thank you to the whole team. It's been incredible, and we wouldn't have been able to have such a smooth bootcamp without everyone. Thanks so much to Zuza, who's really like a master at putting everything together. That's about it. Have some fun. It's time to party and then to sleep for days probably, because we're all exhausted. So yeah, thanks again. Seriously, it's been really great. Good luck with everything. Seriously. Hey.
And for all the students, we'll send you a separate Zoom link where you can hang out together in our beer garden. For all the audience, thank you so much for joining. We hope you enjoyed the time with us.
I can't believe it's over already.
Thanks so much. It was incredible.
Thank you, everybody. Have a nice evening.
That's my poor attempt at whistling.